Or let's start with actually, you know what? Let's start with coefficient and leading coefficient. Coefficient and leading coefficient, they both have almost the same name, right? But one's leading and one's not. So look at A, B, C, D, E, and F, and G. Which ones are coefficients? There's two that are coefficients. Which letter is a coefficient? Which ones are coefficients? So not A, because A doesn't say, definitely has a coefficient, -2. But is there one that says it in the box? D. Yeah, look at D. D is a trinomial, and it definitely has coefficients, but it doesn't say which one. Look at E. The 7, only the 7 in 7x plus 2. So that would be a coefficient. But then look at F. The -5 in this guy. Which of those is leading? 7 or the -5? And not because it's in front. Not because it's in front. Because the 7 has the biggest power, right? That's a 1 here. -5 doesn't have the biggest power. Okay? So the -5 is just a coefficient. The 7 is actually the leading coefficient. That's the difference between them. I don't know why it's blurry. There we go. Okay? So we used E. I used F. Constant. Which one has, by itself, no letter? G, right? G is the 9 in 6x squared plus 4x plus 9. The 9 doesn't have a letter, so that's a constant, G. All right? Monomial means one term. So which of those letters has one term? B. 5x is just one term. Binomial. Bi means two. You're going to see that word a lot. Binomial, you're going to see it a lot on Monday. So that one has two terms. That's going to be A, because that one has two terms, right? Trinomial means 3. D, good. C, we don't have a word for 4 terms, so we just call it a polynomial. Polynomial means many, more than one. So is a binomial a polynomial? Yeah. Is a trinomial a polynomial? Yeah. Okay. All right. So now let's do what we said we're going to do, operations. In math, operations mean one of 4 things. Add, subtract, multiply, divide. Those are the 4 operations. Today we're not doing one. Today I'm not doing division. We'll do division later. We'll do division, but not today, because division's another story. So we'll do it, but not today. So the 3 we're going to focus on is adding, subtracting, and multiplying. Okay? So let's look at this guy here. So let's look inside the parentheses. Inside the parentheses. Are there any like terms inside the parentheses? So in the yellow parentheses, are there any like terms that I can combine? Just in the yellow. Yeah, just in the yellow. No, right? X squared is not the same as X, and then 5 doesn't have an X. It's a constant. So how about the purple? Is there any purple, pink, magenta color? No. Same with those, right? Okay. So we can do that. If you can do parentheses, do parentheses. The next one is, it's subtraction, right? They're subtracting them. But before we can subtract them, we have to get rid of the parentheses. So how do I get rid of those parentheses there? What's the way to get rid of the parentheses? Starts with a D. Not division. Distribute. Yeah, distribute. So to distribute, I have to have something in front. What's in front that we don't write sometimes? A 1. So now we're going to distribute a 1 to everything, right? Distribute means here, here, here. You're giving out, right? I'm giving out a 1 to the 3 terms inside. So when we distribute, do we add them, subtract them, multiply, or divide them? Multiply, right, multiply. So you got positive 1 times negative 3, which is negative 3, right? X squared. Positive 1 times negative 9, negative 9x, right? Positive 1 times positive 5, positive 5, right? Parentheses are gone now. Now I need to do that with the other set of parentheses. So look at the other set of parentheses. What am I going to distribute? Negative 1 this time, not a positive 1, a negative 1 because it had a minus. So you're going to do the same thing. Negative 1 times negative 2 makes positive 2, x squared. Negative 1 times negative 4 makes positive 4x. Negative 1 times positive 7 makes negative 7. No more parentheses. Now take a wild guess. What do you think I'm going to do now? Because you're probably right. Combine like terms. Yep, combine like terms. And when we combine like terms, we always add them. Okay, so let's start with the first one. The biggest power is 2, right? The degree is 2. And here's another one with an x squared. What do I add? The negative 3 and positive 2. Do I add the powers? No, keep the powers the same. So negative 3 plus 2 is negative 1x squared. Done, done. Now go to the next big power, which is just 1, right? X by itself. I have 2 of those guys. Negative 9 plus 4, negative 5x. And then the last one is the degree, or sorry, the constant. 5 plus negative 7, negative 2. No more like terms, no more parentheses, done. Okay. All right. All right, so let's look at number 2 now. Let's look at number 2. Number 2, same directions, still have parentheses, don't have any like terms on the inside. So what did we do when we had parentheses? Distribute, right? So now I'm going to distribute what I have on the outside to what I have on the inside. 1 times negative 10 is negative 10. But now I'm distributing x's. So I'm giving out x's. How many did I have at the beginning? How many did they already have? So how many do you have total? 4, good. And then negative 1 times 1, sorry, positive 1x squared, right? Are those guys like terms? Can I add them together to get negative 9? No, they're not like terms. So once you're done with that, you're done with that. Okay. All right, so we're going to continue doing distributive property, but it's going to look a little different than maybe it has in the past. Remember I told you guys this class looks a little different, looks similar to what I've seen in the past, but we do it a little differently. That's this problem here. Okay, so first of all, I have a parenthesis with 2 terms, and then I have a parenthesis with 3 terms. Am I adding them together, subtracting them together, or multiplying them together? Multiplying. How do I know it's multiplying? You're right.
Because there's no sign.
Yeah, when there's no sign in between, it's always multiplication dots. Always multiplication. If there was a plus in the middle, you do what you did on number 1. Right? If there was a minus in the middle, you do what you do with number 1. But if there's no sign, it's multiplication. So how do I do distributive property when I have 2 terms here? Okay? You're going to build what we call a box, a multiplication box. Okay? So this guy has 2 terms and 3 terms, right? This guy has 2 terms and 3 terms. So that means I'm going to build a 2 by 3 box. Build a 2 by 3 box, right? So I'm going to build a box with one side being 2 and one side being 3. So how's that going to look? It's going to look like a rectangle. There's the outside. One side needs 2. Cut it in half. The other side needs 3. Cut it into thirds. Okay? So the side with 2 is going to get this guy. 3x negative 1. The side with 3 is going to get this guy. Make sure your signs go with it. Make sure your signs go with it. Okay? All right. What do we do now? What do you think we're going to do? Starts with an M. Multiply. Yep, that's what you're going to do. Looks like a multiplication table that you guys used to see, right? So how do we multiply? 3 times 3. 9. How many powers of x do I have? 3. Good. I had 1. Now I have 2. That's 3. Good. 3 times 4. 12x squared. 3 times 6. 3 times 6 is 18. Then I get negative 3x squared, negative 4x, and negative 6. Okay. What do you think I'm going to do next? Combine like terms. Yep, combine like terms. Which one do I start with? Always start with the guy with the biggest power. Is there anything combined with that guy? No. So what do? Write it down. Write it down. Next one. 2. Got 2 of those guys, right? So when I combine those 2, what am I going to get?
9.
Positive 9x squared. Keep it going. Got 2 of these guys, right? Positive 14x. And then the negative 6, there's nobody to combine it with, so he just goes down here. So nothing to combine anymore, right? We're done. We are done. Look at number 4. Look at the next example. How big a box am I going to need for number 4? So do it. Do it. Do number 4 right now. Right? Again, there's no add, subtract in the middle, so we know it's a multiplication. That's how we know it's multiplication. It's not, it looks like number 1, except there's no minus or plus in the middle. So we got 3 terms and 3 terms. So this one's going to be a square because it's 3 by 3. Cut it in thirds, cut it in thirds, cut it in thirds, cut it in thirds. Okay? Since they're both 3, have 3 terms, since they both have 3 terms, right? Does it matter which one you put on the left and which one you put on top? No. Order doesn't matter for multiplication. So 4x squared, positive 7x plus 3. Multiply again. Multiply like you did on the last one. So we got 1 times 4, which is 4. x2 and x2 make x4. 4 and negative 3 make negative 12. x2 and x1 make x3. 4 and 4 make 16, x2. 1 and 7 make 7, x3. Negative 3 and 7 make negative 21, x2. 7 and 4 make 28x. Last row, 3 and 1 make 3x squared. 3 and negative 3 make negative 9x. And negative, or positive 3 and positive 4 make 12. So if you reversed them, you'll have your numbers in other places. But you should have boxes. Every one of you should have a box with 4x to the fourth, negative 12x to the third, 16x squared. Those will be the same. They might be in different spots, but they'll be the same. Last step, combine like terms. That guy, 4x to the 4, doesn't combine with anybody. We got x to the third next. Was that negative 5x3? Then we got x squared is the most. We have 3 terms that are x squared. So what do we get? What do we get? I think it's 2? No. Yeah, negative 2. Yeah, negative 2x squared. Remember, when we're combining like terms, you don't add the exponents. Leave the exponents alone. The next one, what do we get? 19x. And then the last one, 12, doesn't have anything to combine with, so we just move it down. Is it 21? Where is it? Which one? Oh, we talk about 28 and 19? 28 plus 19 is actually, it's 19. Or 28 plus 9 is 19. Yeah, 21, let's see, or 28, sorry. I keep saying something different. 28 plus negative 9, 19. Yeah, in fact, I put 21. First period, I put 21 and it was wrong. I had to change it. Okay. Okay, one more question. Give me 1 second. This one involves everything. They created one problem that has distributive property that we're going to need to build a table or a box for that has combining like terms. Because it involves everything, you're going to see this one. This one, they always have. This question here, they always have on tests and quizzes. Always, 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 100% of the time. 100% of the time. And also, sorry, there's supposed to be a 3 in front. There's supposed to be a 3 in front. I don't know why I got cut off when I printed it, but it's supposed to be a 3 in front. Okay. So what do I do first? Okay, so first, students always want to do this. Distribute, distribute. Can I distribute the 3 to that guy there? Ricardo, I got your focus up here. Okay. Can I distribute that? No, I can't. Why not? Because it has a different power. If that power wasn't there, go for it. You can do it. But if it has a power there, it doesn't matter what, you can't do that. So we got to think of it a different way. So what we're going to do first is we're going to deal with exponents first. Who does that 2 go with? It goes with the parentheses, right? It goes with these guys here. So that guy's squared. So what does squared mean? Exactly, multiplying by itself. So I'm going to go on a little side quest here, and then I'll come back to it. So here we go. X plus 4 squared, right? It means multiplying by itself. How do we multiply those 2 guys? I'll give you a hint. You've done it. You just did it. Within the last 10 minutes, you've done it 2 or 3 times. How do we multiply them? Using a box. Yep. This one's got 2 terms. That one's got 2 terms. We use a box. 2 by 2 box. So 1x times 1x makes 1x squared. 1x times 4 makes 4x. 1x times 4 makes 4x. And then 4 times 4 makes 16. Do what you did. Combine like terms. We have x squared plus 8x plus 16. I'm going to go back to the problem. I took a detour, but now I'm going to go back. Okay, I'm going to stop right there for a second. I took a little detour to take care of exponents. Now I'm going to go back to the problem. Everything in black that's not highlighted, I'm going to rewrite. The 3 in front, the parentheses, the -4, the parentheses, the +6, I'm going to rewrite. The only thing I'm going to change is what I highlighted, because what it is x squared. I took care of exponents. So that's x squared plus 8x plus 16. Okay. Now, I don't have to worry about exponents anymore. Now, I can distribute because there's no power anymore to block it. So I can distribute this guy, I can distribute that guy. 3x squared, 24x, plus 48. Distribute -4, you get -4x minus 16. And then the positive 6 comes down with it. Combine like terms. Well, this guy can't combine with anything. This guy can combine with this guy. Positive 20x. And then this guy can combine with this guy, which can combine with that guy. So when you do that, you get positive 38. Done. Okay, I'm going to give you one more problem to do in your notes. Where is it going to go? We have no room. Well, you do. Look on page 11 in your notebook. It's blank. It's blank. You're going to do one more problem. When you tape it in, you're just going to tape in the top. You're going to tape in the top so you can see what you did underneath. Okay? I noticed on the test, you guys, a lot of you use your notes, which they're there for. That's what they're there for, right? The more notes, the better. So one more problem, and then we'll be done for today. Okay, we got just enough time for one more problem. So this is example number 6. Same directions, go ahead. Yeah, when you have time in your notes. Okay. I'll write it down. I'm going to write it down right here. It's the same directions as number 5. Same directions as number 5. Do that one. Okay. It'll be on Google Classroom too, yeah. Okay. We're going to practice more tomorrow. All right. Tape's in the back. Grab tape, pass it around. Just when you're done with the tape, put it back in the back, please. Don't leave it on your desk, because my next class don't use tape. So if you're done with it, just put it in the back, put it back. See if anyone around you needs it. So you're going to tape that on page 11.